Good morning, good students. In our previous class, we learned about gravitation, centripetal force, Kepler's laws, and Newton's universal law of gravitation. We also saw the effect of force by changing the distance between the two objects. When the distance is doubled, that is when d becomes 2d, then the new force is decreased by a factor of 4, which is equal to 2 squared. Similarly, when the distance is tripled, then force of gravitation is decreased by a factor of 9, equal to 3 squared. This made Newton assume inverse square dependence on distance in his law of gravitation. Let's derive Newton's inverse square law. When a planet is moving in a circular motion around the sun, the centripetal force acting on the planet is given as F is equal to m into centripetal acceleration. This was your force equation studied in standard 9th, which will be equation 1. F is equal to m into v square upon r, where m is the mass of the planet, v its velocity, r is the distance between sun and planet. But we know that v is equal to distance upon time. The distance travelled by the planet in one revolution is equal to perimeter of the orbit, which is the circumference, 2 pi r. And the time taken is period of revolution, t. Squaring both sides, we get v square is equal to 2 pi r upon t square. Substituting this in equation 1, we get F is equal to m into 2 pi r upon t square divided by r. Squaring, we get F is equal to m into 4 pi square r square upon t square into 1 upon r. Cancelling the common term r, F is equal to m into 4 pi square upon t square into capital R. Multiplying and dividing by r square, we get F is equal to 4m into 4 pi square upon t square into r cube upon r square. On rearranging, F is equal to 4m pi square upon r square into r cube upon t square. According to Kepler's third law, t square upon r cube is equal to constant k. Applying invertendo, r cube upon t square is equal to 1 upon k, which we substitute in equation 2. So, F is equal to 4m pi square upon r square into 1 upon k. On rearranging, F is equal to 1 upon r square into 4m pi square upon k. Now students, mass of the planet is a constant. So 4m pi square upon k, the entire term becomes a constant. So we get F is equal to 1 upon r square into constant. And the relation between force and the distance r is as follows. Force is inversely proportional to r square. This is the inverse square law of gravitation. Using the above derivation, Newton gave us force is proportional to m1 into m2 upon r square. Thus, Newton concluded that the centripetal force, which is the force acting on the planet and is responsible for its circular motion, must be inversely proportional to the square of the distance between the planet and the sun. Newton thus identified this force with the force of gravity and hence postulated the inverse square law of gravitation. Hope you all have understood the inverse law, square law of gravitation, students. Now we go further to understand motion and gravity. For this, please watch the following video.